Suppose you want a chatbot that can actually look at a picture and talk about it. The obvious plan is to train one giant model on images and text together, which costs a fortune. Back in 2023, a paper called LLaVA showed a far cheaper trick. Take a vision model you already have, take a language model you already have, and glue them together with one tiny layer. That's it. Let's walk through how it works. To see why this recipe is so clever, let's follow a single image as it travels through the system. It starts with a frozen vision encoder, specifically the image side of clip. Frozen means nobody touches its weights during training. It looks at the picture and turns it into a bundle of feature vectors that capture what's in the image, from objects to layout to texture. And because clip was already trained on huge amounts of images paired with captions, those features are rich and language-aware right out of the box, which is exactly why LLaVA can lean on them without any extra vision training. Then comes the star of the show, a small projection layer. This little connector maps those image features into the exact same space the language model uses for word embeddings. After the mapping, the picture literally becomes a handful of visual tokens the model can read like words. Now the language model, something like Vicuna, receives those visual tokens sitting right alongside your text prompt. As far as it's concerned, the image is just more tokens in the conversation, so it reasons about the picture and your question at the same time. And out comes the answer, plain generated text. Describe the scene, count the people, read the sign, explain the joke. All of that flows through a connector you could train in an afternoon. The genuinely surprising thing is that a single lightweight layer, sitting between two frozen giants, is enough to teach a text model to hold a real conversation about what it's looking at. Here's the real shift, side by side. The heavy approach trains one enormous multimodal model from scratch, learning vision and language jointly across billions of examples. It works, but it burns enormous compute, and most teams simply can't afford to attempt it. LLaVA freezes the two expensive parts, the clip encoder and the language model, and trains only the small connector between them. Almost all the intelligence is already there. You're just teaching a bridge to translate pictures into the language the model already speaks. Now, let's name the three ideas really doing the work here. Reusing frozen models is the first idea. A pre-trained clip encoder plus a projection connector means you inherit powerful vision and powerful language without paying to train either one again. Visual instruction tuning is the second, and it's genuinely clever. The team prompted a text-only version of GPT-4 with image descriptions to generate multimodal conversations, then tuned LLaVA on those synthetic dialogues. So the training data for a vision model was largely written by a model that couldn't even see, which turned out to be a remarkably cheap way to teach genuine visual reasoning. Punching above its weight is the payoff. With a tiny connector and modest data, LLaVA rivaled far more complex systems and kicked off a whole wave of open vision and language models. Alright, let's lock in the essentials. LLaVA connects a frozen clip image encoder to a language model through one small projection layer. That projection turns image features into visual tokens the language model reads right next to your text. Training uses visual instruction tuning, with multimodal conversations generated by prompting a text-only GPT-4. Because both big models stay frozen, you get strong open multimodal chat for a fraction of the cost, which is why LLaVA became a template countless open projects built on. Craving more AI ideas unpacked without the jargon? Wander over to Standarity.com and dig in.